Okay, so now we're going to look at the examples that go with fundamental theorem of calculus notes. So again, make sure you have printed out those notes and you have read through them. Also, make sure that you have watched the videos that I posted previously of the Riemann sums and the inscribed and the circumscribed rectangles, and so you're familiar with the stuff that we're going to talk about in this video. So now we're going to evaluate definite integrals. And we're going to be finding that area under the curve, and instead of doing those inscribed and circumscribed rectangles, we're going to be able to evaluate him like this when doing that basic power rule that we looked at before. All right, so first thing you want to do is, look at your problem and you want to integrate it. All right, so add 1 to the exponent, divide by the new power, and integrate the 5. We just stick on the x. All right, so if I simplified that, we've got 2x cubed minus 5x. Now, these are definite integrals because you've got those limits of integration, that -2 to 3. So you're going to draw me a line. Instead of doing the plus c, we're going to evaluate this from -2 to 3. And so the easiest way I do it is I draw myself like 2 circles. All right, and then the first one you want to plug in the top number, and in the second one you want to plug in the bottom number. And we want to do this math out. Now, obviously you're going to, probably use your calculator and then plug this all in. I'm going to do this first one out, and then I'll kind of tell you what you should get on all of those. 2 cubed is 27. And then this one is -2 cubed is -8, and that'll be a plus 10. So that would be 2 times 27, 54. 54 minus 15 is 39. And that's going to be a -16 plus a 10, or a -6. So I end up with 39 plus 6. So the area that I get, that evaluating that definite integral, gives me 45. And so again, remember, in the first circle, you want to plug in the top number. And in the second circle, you want to plug in the bottom number. And I'll kind of now be using my calculator to do it a little bit more quickly as we go through these. All right, so we need to integrate this, but before I can do that, I need to simplify it. One term on the bottom, so I need to think about it as splitting it up like that. So if I were to subtract my exponents, I end up with the integral of x to the 1/2, because you're doing 1 minus a half. And if I bring this one up, I get 2x to the -1/2. All right, so that's one I want to integrate. So I'm going to copy it down. All right, so add 1 to it. I'm going to write my 2 over 2. I get a new power of 3/2. Dividing by 3/2 is the same as multiplying by 2/3. And then add 1 to it over here, and I get plus 2 over 2 would be 1/2, and dividing by 1/2 is the same as multiplying by 2. All right, so I get 2/3 x to the 3/2 minus 4 x to the 1/2, and I want to evaluate this from 1 to 4. I should have copied them over here from the problem. Okay, so I'm going to move it up here so I have a little bit more room. So I'm going to plug in the top number and plug in 4. So I get 2/3 times 4 to the 3/2 minus 4 times 4 to the 1/2. And over here I am plugging in the 1. All right, so when you evaluate that and plug that all in, I got a -8/3 for that. And I got a -10/3 for that. So I end up with -8/3 plus 10/3. So I get 2/3. You could also give me that decimal answer. I would round it off to 3 decimal places. Okay. All right, let's look at a trig one. We've got the integral from 0 to pi over 4 of secant squared x dx. And so we know whose derivative is secant squared. That would be tangent. Got to know your trig. I need to evaluate tangent at pi over 4 and tangent of 0. Well, I know the tangent of 0 is just 0 when I think about what the graph looks like. Many different ways to know the tangent of pi over 4. I always think about my triangles, and a pi over 4 triangle would look like this, and tangent is the opposite over the adjacent, so 1 over 1 or 1. Okay, make sure you are able to evaluate all those trig functions. Okay, and then if we go on to the next example, we looked at some pictures are in the notes, but we want to find the area of the region bounded by the graphs of the equations y equals x cubed plus x equals 2, and y equals 0. All right, so I know x equals 2 is going to be this line right here. All right, y equals 0 is the x-axis. So there's my y equals 0 line, there's my x equal 2 line. So I just need to kind of get a picture of what the other one looks like. So if I think about a t-table, all right, I'm going to see if I put in 0, I would get 0. If I put in 1, I get 1 cubed plus 1, which would be 2. If I put a 2, I get 2 cubed plus 2, which would be 10. So I've got 0.00, 1, 2, and 2, 10. So I've got this picture. So I want to look at this. Okay. So that's going to be the integral, and you're going to get, this becomes a and b. This is, so a is equal to 0, and then b would be 2. So you want to go look and grab those off the x-axis, where to start, where to stop. So I'm going from 0 to 2, and I want to integrate this. Okay. So let's power rule it. So add 1 to it, divide by the new power, and I end up with 1/4 x to the 4th plus 1/2 x squared. And I'm going to go from 0 to 2. All right, so if I plug in the 2 here and the 0 here, that's just going to zero out, because when you multiply both those by 0, that goes away, and that would be 1/4 times 16 plus 1/2 times 4. So we don't need our calculator to do that. That just ends up being 4 plus 2, or 6. Okay. And then I gave you some theorems from the book. We looked at mean value theorem and the average value, the second fundamental theorem of calculus. But here's just an example where when we looked at the mean value theorem in the notes, it doesn't tell you how to find C. It just tells you, it guarantees you that it exists, some true area, some value of C in between those inscribed in those circumscribed rectangles. So here's how to find that C. Okay, so here's the process. First of all, that interval they give you, A is 4, B is 9. So first thing you're going to do is integrate it from 9 to 4, and it's going to be x to the 1/2. All right, so if we did the power rule, add 1 to it, divide by the new power. So we get 3/2, and divide by 3/2, same as multiply by 2/3. So I get 2/3 x to the 3/2 from 4 to 9. Sorry, I've got a little bit of a cold. All right, so I get 2/3 times 9 to the 3/2, and 2/3 times 4 to the 3/2. So if you work that out, I got 38/3 when I did it. And so now you want to use that formula to figure out what that value of C is. And so the formula is integral from A to B of f of x dx is equal to f evaluated at C times B minus A. And we want to just plug into that formula. Well, we just figured out what this was. When we used our problem, we got 38/3. All right, f of C is just going to be, take your original function, replace the x with the C. So that would be square root of C, and B minus A is just 9 minus 4. So what we want to do is take this and solve for C. So we get 38/3 equals square root of C times 5. So I'm going to divide both sides by 5, or multiply by 1/5 to cancel that out. So I got 38/15 would equal the square root of C. And so to solve for C, I'm going to raise both sides to the second power to cancel out that square root. So when you do that, you get 1,444 over 225 equals C. And so that's how you would actually find that value that that mean value theorem says exists. All right, and then very last example, we're going to find the average value. Okay, so we've got our average value formula in your notes, but first thing I'm going to do is integrate it. But when I look at it, I'm going to think about, oh, I would distribute my 4. And then if I divided it out, I end up integrating from 1 to 3, because then this tells me that A is 1 and B is 3. Okay, integrate from 1 to 3, I would get 4. If I divided both those by x squares, the x squared would cancel, and then I would get 4x to the negative 2. All right, so this is what I want to integrate. All right, to integrate the 4, I'm just adding on that x. Here I'm adding 1 to it, divide by the new power. So I get 4x plus 4 over x. And I want to evaluate this from 1 to 3. All right, now the average value formula says get this, okay? So if I plug it in, I get 4 times 3 plus 4 over 3, and 4 times 1 plus 4 over 1. And so when I did that math, I got 32 thirds. And so the average value is equal to 1 over b minus a times that integral evaluated from A to B. So we found that, and that was 32 thirds. And so this would be 1 over 3 minus 1 times 32 thirds, or 1/2 times 32 thirds. And if I cancel it out, I get 16 thirds. That's my average value. All right, so make sure you go try your homework.